Well, while people are drifting in, I'll kind of wade into things here. We've got the session today broken up into three different parts. We've got a research session before break this morning. We've got a water session for the rest of the morning, then lunch, and then a reclamation session for the afternoon. And be sure to recognize our sponsors in the other room and thank the exhibitors. Drawings for door prizes will be held after lunch, before the break. Lunch is provided, just like yesterday, for everybody. There will be a hospitality suite this evening, sponsored by Pioneer Technical Services. If you want to sign up for professional development hours, that's at the registration desk. A full recording of all the presentations will be online 2 to 3 weeks from now. If you're presenting tomorrow, please attend the speaker's breakfast at 7:15 in the restaurant. And also, please fill out the conference evaluation forms. Believe it or not, when I was involved and when Warren was involved, we actually look at those and use it to determine what we'll come up with next. So, without further ado, we'll get started. The first presentation is by Brant Winkleman with Technology Solutions in Bozeman. He has a bachelor's degree in environmental physical science and a diverse background in electronics, fabrication, integration, and geospatial science. He's worked as a GIS manager and a data analyst, and he's going to be talking about UAVs and remote water sampling applications for toxic water. Brant?
Thank you. All right, good morning. I'm the opening band today, so thanks for getting down here. As he mentioned, I work for a company called Fairweather IT. We're out of Bozeman, and we do applied science and technology services. We do some remote sensing work. We also do photogrammetry and UAV water sampling, which is more what we'll be focusing on today. And also some USV work. So those acronyms, there's a lot of acronyms floating around in here. I'll try to call them out. UAV is uncrewed aerial vehicle. USV is uncrewed surface vehicle. And we have a handful of other special projects. I'll go through some of the equipment that we have that we use for this stuff. Our UAVs, we have some heavy lift drones from Watts Innovations. It's an American company. We have the MFD, which is on the bottom right down there, very large craft. It's probably about 7-foot wingspan, so it's big. We also have some Prisms, which is sort of the follow-up vehicle from that same company, and that's down on the left. We have some DJI craft that we've sort of been moving away from. And we also do have a Wingtra, which is a VTOL that covers large areas for survey work. The USV Arsenal is made up of a handful of water hazing craft, which you may hear briefly about later today. Those are used on the Berkeley Pit for waterfowl hazing. There's a couple different boats there. The Water Dog is sort of a little chase boat. That's the blue one on top. Then the pontoon boat carries a heavier load of some sound equipment to also try to scare stuff away. And we also have a few land vehicles that work well as test platforms because we don't often have open water around here. So have to test it elsewhere. And we also do have a few ROVs, which is just remotely operated vehicle. It's a tethered thing like a little submersible. That picture in the bottom middle is kind of the heavy duty one. And we also have a smaller version of that that basically doesn't have the bottom tier on it. And a drop cam that we've set up for going down mine shafts, and that picture on top shows you that. So where do we work? For the most part, we work in mining remediation sites around Butte and Anaconda, on occasion elsewhere in Montana. And the Berkeley pit is sort of the focus today. So even though most of us have some familiarity with what that is, for the sake of completeness, I threw this in. Used to be a large copper mine. It's now an active remediation site over in Butte. It's been filling with water since the 80s. It's very large, roughly a mile across, 800 plus feet deep, low pH water and high in concentrations of metals, and hydraulically connected to a huge network of underground. So the nature of this pit makes it very difficult to work on. You can't go out there on manned boats, so that's where the UAV aspect really comes into play. There's the water itself is part of the reason. There's potential for instability in the walls surrounding it. So in the interest of safety, they really just don't want anyone out there, and that is where we have come into play. So in terms of the water sampling, some of the stuff specifically that we use is, as I mentioned before, these heavy lift drones. One of them is this Prism. It is in an X8 configuration. So you can see in the picture there, it's got 4 arms, but there's 2 motors on each arm. So it gives you a vehicle with a lot of lift that is in a little more compact version than having arms sticking out all around. It runs on a Pixhawk, which is a open source version of the autopilot. It's kind of an answer to some of the moving away from DJI that's happening in different industries and agencies, which is probably the more consumer drone. It's a 44 volt craft, 32 amp hour battery pack. Its battery pack probably weighs as much as the craft, so it's carrying around a lot of energy, and we can fly for about 25 minutes with that. The other one is this MFD, same thing, comes from the same company. It's a hexacopter, so you can see it has 6 arms sticking around it. Probably has a little more lift than the other one. The craft's also outfitted with a radar rangefinder, so at the pit we're often 60 meters above the water, flying half a mile or more away, trying to float a little ways above the water, and you can't really see where you're at in relation to that stuff. So that rangefinder just gives us an idea of how far are we above whatever we're above, which especially in that relationship is very important because you can't land it. Kind of the same setup, big battery pack, probably doubles the weight of the craft, and we also get about 55 or 25 minutes of flight time on that. So while that's not a huge amount of time, both of those craft can carry up to the legal limit of just under 55 pounds. So that is why those are helpful for this water sampling. So a few of the implements that we've set up for mounting to these are the WASP here, which is just an acronym for water sampling plate. Some of you may have seen something about this before. My colleague gave a talk on this a year or 2 ago, I believe. It is remotely operated by a second person. So there's the pilot, and then there's an equipment operator that has their own remote control, and it's set up with a few special features for doing the water sampling work. It's got a payload winch on it, so we can send stuff much further down than we would be able to with a sling load, just due to height restrictions for flying. So we've been able to send a little sensor over 800 feet deep with this. And it's got a payload dropper, which you'll see in action in a video here in a minute, and line cutter for a backup. if you need to get rid of something that is trapped. And the camera is just kind of used for being able to manage the movement of the payload with that winch, so the operator can see what's going on. We made a little simpler piece to take out for some of the recent work that we're doing, which you'll see in the videos as well. It is just the payload dropper and a different gimbal camera, partly to cut weight and partly to keep us from carrying more technology around than we need to. The camera on there is both for viewing, and then we can record video of what we're doing. And one of the videos we'll watch is recorded from there. So water quality data. Some of the stuff we've been using for sampling is this sonde, which is a 6-parameter probe that does pH, temperature, depth, conductivity, dissolved oxygen, and turbidity. The way we often use that is with that payload winch, send it down in a location at a fixed speed and pull it back up to do profiles. The Star Odie is in that other picture. It's the much smaller of the two. And that we tend to use just for the depth reading to attach to stuff that doesn't have depth built into it. For example, when we're grabbing a physical sample, there's not other sensors worked into that, so that Star Odie goes on just so we can know what depth we got down to when we pull water. This hydro sleeve has been how we've gotten a fair bit of the physical sample that we've collected. It's just a valved sleeve with a weight on the bottom. You send it down to whatever depth roughly that the people that want the water sample are interested in. We have those reels set up to where we kind of know they'll go down roughly at some amount of distance per second, so you can kind of ballpark it with time, but get the specific depth with the sensor. Yep, and then when you pull that up, the valve opens and you get a sample from whatever depth that was setting at, and then reel it back up to the craft and bring it home. So to date, we've had about 126 sampling locations. You can see the distribution there on that map all over the place. We roughly take off from this area. So a lot of these are, 3/4 of a mile away. It is pretty exciting to take that much equipment and money that far away over a pit of acid. So a few of the more recent things we've done, we're looking at trying to set up some ways to measure turbidity that aren't a specific sensor. There is turbidity on that sonde that we talked about. This is more for water clarity relative to other times. So the idea with these is you take them out multiple times to compare. And then the Imhof Cone is a sedimentation cone that we've been suspending in the pit to try to get some samples. So the Cetchy Disk, as I mentioned, it's normally used for lakes and I suppose maybe streams to try to look at turbidity from either maybe natural things like phytoplankton or runoff from human caused activity. We tried to just do that instead from a drone because we can't go out there on a boat. So using that camera and having this hooked up to a line, the way the deployment works is you lower it into the water. If you were on a boat, you'd obviously be much closer to it until you can't see it. Mark the line, lower it down a little more, pull it back up, mark the line when you can see it again. And just that average of those two lengths is kind of your ballpark of how far down into the water column you're seeing. So to try to do something like that on the pit, we did it from the drone. this picture on the bottom, what we did was just mark out 1 meter increments on the line to try to have just a ballpark way to move in specific distances. We have a spotter on shore that's also helping at an oblique angle, because you'll see in the video it is difficult to tell exactly where you're at. But that radar rangefinder that I mentioned that gives us how high we are above the water also aids in knowing where we're at. So go ahead and play that. So this is a little video spliced together of, this is all from that gimbal camera on the drone. So we're taking off. You'll see up there in the corner, we've got a ground station where we work from and the spotter that's watching through a spotting scope. Speed up here so you don't get bored watching a drone fly over a green empty space for too long. So you get out to location, face that camera down. We're about 60 meters above the water, so we lower down to the water. Here we're pretty close to the surface of the water, and that disc goes in here in just a second. So right there where that line goes slack, then between the radar and the person on shore, we're trying to get an idea of did we get stopped at that first knot? So that's a meter. You get down to that second meter, it kind of becomes hard to see. You can just barely make it out. I think easier to track it on the way down when you know where it's at. And then here he'll move down again in a second. And so at that point, you can't see it anymore. Being unsure what we could see, we went ahead and went through all 5 steps, because you can see a lot better on the video than on the little screen in the sun. But so here's on the way back up, that 2 meter zone, really pretty hard to see, but we'll see it pop up here in that last meter of water coming out. So this was just the first time we tried this, just to test to see if this is even viable way to kind of get a ballpark idea of what water clarity is like. And here we just quickly are flying back. That payload dropper that is under the craft that I showed a picture of earlier is handy. This is also sped up. We're not actually flying quite that fast, but is a handy way to just get rid of this equipment before you're trying to land, because you don't need 10 meters of string flapping around in your propellers while you're trying to come down. So we can come back, drop off whatever thing we've taken out there. In this case, it's that disc. And I just walk over there to grab it to keep it out of the props in case the breeze picks it up. And that is that. So can we go to the next? Okay, so the other newer thing I mentioned is the Imhof Cone. That is a sedimentation cone that is typically used for wastewater, effluent, or well water measurements. Again, we wanted to set this out and leave it in the pit for a period of time. This first one we tested for about a month. It's ultimately the sort of lobster float here and 30 meters of line, and then this cone is just tied to the bottom of it. So we left one out for a month, then we went and put 3 more out there once we realized that we were able to retrieve this, and left them out for 5 months. You'll see here, this picture on the right is the first cone that we retrieved, and then that other picture is just of the next ones we put a larger hoop on to try to capture that with. So go ahead and play that. So here again, we're at that same access point of the pit, and as this goes up, you'll see that float right under the drone. We got our 30 meters of line, And I think probably till we're over the water, it's hard to see the cone. So you got to kind of drag it around to get a little water in it to get it sinking. And once it's sinking, we just go closer to the surface of the water to drop off the float. And here we're down there and release the payload. It got a little hung up, so we had to give it a little wiggle. And there it sets for a month. There it did not set for a month. It drifted across the pit as far away from us as it could possibly get. So we go back out about a month later, kind of the reverse operation, except this is more like if you were playing that arcade game where you're trying to grab a stuffed animal with the hook, except the hook is a $50,000 drone and the stuffed animal tank is a massive acidic lake. So we get out there, we're lowering down. There's a grappling hook on the end of this line to try to hook the float. This was the first one. That little hoop was not quite as easy as we had imagined, so he ended up setting the hook in the float itself. And you'll see here, that's some high-tech fishing, basically. And once we get a hold of it, then we can pull it up. And so that's that 30 meters of line. And here in just a second, we should see the cone pop out. So there's the cone, and then we fly it back. You can see how much further away we are, basically flying to the other side there. All of this stuff was flown in tandem with another small drone for video, so that's why we get all the close-ups. So again, we bring that payload in. This is a lot more swingy than the little metal disc that we saw in the other video, but you can kind of see this is sped up, but we'll sort of let the cone go forward and fly the drone over it to try to limit the pendulum effect that we're getting there. The person in the orange there is gathering the cone. And then I walk up there with that separate remote controller to drop the payload off. You see it fall down there, then I'll just drag it out of the way. And then the third person that's the pilot in command then just lands the craft. So that's that. And thank you. So what did we learn from that stuff? One, that Cetchy Disk is not as visible, as deep as we thought, so it'd be worth putting on a shorter line just so we could be closer to it visually with that camera. We would also like to maybe mount that Starody little depth transducer piece to it so we could go down, set for 30 seconds or whatever, and then that way there's a signature in that log data of each depth, and then we can kind of correlate that with the video. And it'd be worth doing a validation test too, now that this seems at least somewhat plausible, just to go to a regular body of water and do it with a boat, then go back and do it with a drone in the same location. Lastly, for the Imhof cones, one of those, the anchor did get sedimented into the ground and we were unable to pull it out. That was a sporty time because the drone's trying really hard to yank it out and it's not giving. So that one lives there now. So we're considering trying to put some sort of weaker breakaway below the cone so that if the anchor gets stuck, we could still retrieve the cone. And I think in the future, we also have considered putting a GPS, some kind of cheap GPS system on it, because they do move all over the place over a long period of time. And there could be interest in where it's at, different points of its path. We may also try to incorporate something simple like a temperature sensor just to get some other information on there. So I'd like to thank, all of our cooperating partners at Atlantic Richfield, Montana Resources, Pioneer, and Alloy. And at that, I can take any questions if anyone has any. Yes.
So a couple questions on the battery power. So seems like 25 minutes isn't a lot of time, especially if you're having problems. So you have a pack that can just be swapped out immediately, or does it have to charge?
Yeah, so the question's about battery power. We have four flight packs. So and then we have a charger we can take on, so we can actually charge the first one while we're out. And I mean, we could probably do 5 or 6 flights easily without any waiting. So yeah, we can kind of go around and around, but you only got to come back to change it out. So.
And the follow-up question, is there a wind limitation? I suppose you have to do it pretty calm days.
Yeah. I mean, especially depending on what you're carrying around, we usually have a limit that we put on at, I believe it's, I want to say 15 miles an hour, maybe. That'd be a little much with that big cone. Something smaller like that little Cetchy Disk or something that we have sucked all the way up to the bottom of the drone, then that doesn't cause so much trouble. So some of it depends on what you're carrying around too. Yep. Anything else?
What was your longest flight? How close to 25 minutes did you go?
So 25 minutes is about what we can do with all that equipment on there. That's also ending up carrying around a 45-pound mass of stuff. So if you were carrying something smaller around or didn't have all that payload on there, then those craft can fly longer, but we're just kind of pushing them to the max of. Yeah, 20 probably. I don't know that we go out to 25 too often, but.
And then the other question I know from Jeremy and Mark.
Yeah.
You're in the flight path for the airport.
Correct. Yeah. So we get a flight waiver for each time we go out. Yep. Yes.
So do you currently use DJI or?
So no, we've largely moved away from DJI. The vehicles that I was showing in there were from a company called WASP Innovations. I think he's in Maryland, maybe. But yeah, he builds heavy lift drones that have more open source brain in them, basically. So that's what we've been using. It's easier to integrate other stuff into it then too. I mean, if anyone's used DJI stuff, like they work great out of the box, but if you want to do something unique to them, good luck.
Other questions? Thanks, Brent.
Yes.